Welcome from my side. Welcome to this session on caching and messaging improvements in Spring Framework 4.1. You may wonder why caching and messaging in the same talk. There are a couple of reasons, I suppose. The same people working on it, for example. But I would hope it's also relevant, I would say, to the same kinds of classes of applications. The session is actually being split into two parts. So we have a caching section and a messaging section. We'll start with caching. Messaging is the longer one. So the initial caching part is about in the 20-minute ballpark. We'll spend the 25 minutes maybe. We'll spend the lion's share of the session on messaging, and we'll have a demo for you on messaging. All right. Who's speaking here? The two people actually involved in the caching and messaging part. Stéphane here is actually the lead developer on both themes in the Spring Framework 4.1 release. So maybe you want to introduce yourself quickly?
Yeah, I'm working on open source. I'm involved in open source since 10 years now. I've been involved on the Apache Maven project quite a lot. I'm a PMC member of that. And joined Pivotal this year to work on Spring, and I'm also working on Spring Boot right now. So the idea is between each sessions we'll have QA, so you get a chance to ask any question you might have. If you still have questions after the talk, there's still a few days to bump into one of us and ask your question, or if you're really, really shy, you can try the Twitter mention, and Juergen is actually reading his tweets.
Yeah.
I don't know
the replies are going to come from your account, but I'm going to read
I don't know where he's going to tweet his first tweet, but he's looking at his account, so you can check it out.
Yes. All right, but it's an important point. After each section, we'll have a chance for Q&A before we move on to the other half. All right, let's get started with the caching part. We'll have a bit of a recap for you, but we'll keep it brief. So what's the state of the art, basically, that we started with from the Spring Framework 3.1, 3.2, 4.0 generation? There's a traditional Spring style of handling interaction with caches, which I suppose most of you are at least somewhat familiar with. This is an annotation-based model where specific methods in a typically service interface maybe would be annotated with like @cacheable or one of its siblings. The typical use is a lookup method with a list of arguments coming in. The key is being calculated, composed from the arguments. The @cacheable may specify the cache region that it's supposed to do its interaction with. And the interaction pattern is as you would expect it to be. When we try to enter the method, we perform a lookup, we calculate the key, perform a lookup in the associated cache region. If we find an entry and it's still valid, we'll return it and we'll never ever invoke the target implementation of the method. If we have not found a valid matching entry, we will invoke the target method, your implementation of that method, let it return, and take the return value and put it into the associated cache region with the same key. So it's a typical lookup pattern. If there, return it. If not there, calculate the value, cache it, and return. So a declarative version, basically, of cache interaction. There's a couple of flavors of doing this already. That's still Spring 3.1 plus. We can specify how to calculate the key, for example, with a spell expression. So that's a nice way of actually customizing or more specifically interacting with the cache. There is the @cacheput variant that just says, like, whenever you invoke that method, while you're at it, also put this object into the cache. So that's a kind of the half of @cacheable, basically. And there's cache-evict that says whenever we hit that method, go into the cache and remove the associated entry. So that's basically the state of the art as of Spring Framework 3.1. There have been a couple of improvements in 3.2, but this is basically what we started with. In terms of how you would configure this, of course you can do it with the usual way, namespace-based. But if you look at the Java-based version of it, the central part is selecting a cache manager implementation. So what you can see down here is the typical @bean method in a configuration class that just builds a Spring cache manager implementation. So there is a central SPI here, which is the cache manager SPI. That's a Spring cache manager interface, and several implementations that Spring Framework itself comes with, or implementations that are being provided by other projects around us for other kinds of cache backends, like for Gemfire, Redis, and so forth. All right, and so this is basically what we have. There's @enable caching up there, enabling the typical cache processing infrastructure. That's the annotation-based processing part. Very analogous to the cache annotation-driven XML element. All right, so what's new in Spring Framework 4.1? Quite a bit.
Yeah, and what we're going to show now is mostly based on users' feedback. So the idea here is we are trying to start from that example that we've shown you and demonstrate new features in Spring 4.1 and see how we can simplify the declarative ways of enabling the cache aspect. So the first thing that we've added in Spring 4.1 is class-level customizations. That's, if you're using the caching infrastructure already, that's something you may have used in the past by putting, for instance, the cacheable annotation at class level with the name of the region to use. And what that would do is basically apply the cache aspect to all public methods of that class. The advantage of doing that is you can share the cache name, so you don't have to repeat the cache name over and over again. But the downside is if one of those public methods do not have any caching business at all, it's being wrapped anyway. So what we've done is adding a new annotation that you can put at class level of any service called cache config. And on that annotation, you can share common settings that are being applied to the service without enabling any caching aspect at all. So you still have to annotate your public methods to whatever cache aspect you want to apply. So in this case, we've moved the books region name to that annotation, which allows you to prevent the copy-paste, the nasty copy-paste between the four methods. Oh, right. But we still have a quite complex spell expression in there. What it does, if you're not familiar with spell expression, it's calling a static method called resolveBookID on a class called bookIDResolver, and it's passing the ISBN argument. So the argument of the method is being passed to the expression. As you might suspect, what that does is just figuring out the string ID out of it and use that as a key. You may want to push that code away and make that a dedicated class, and so that you can test it more easily and whatnot. But the problem prior to Spring 4.1 is there was no way to customize the key generator per operation or per service, by the way. So that's what it would look like, pseudocode. So basically extracting the ISBN from the parameters and calling a method that's going to, well, calling the same method actually, that's going to create the ID. And you can test that in isolation without the caching aspect. You can just make sure that if you pass the right parameters, you'll get the right answer. So now you need to customize it, right, for that specific operation. So for that, we've improved all the annotations to be able to specify custom services. This applies to the key generator and the cache manager. So that's yet another user feedback that we got. People using an application with several cache managers and being forced to create a composite or something that would look to proprietary annotations to figure out which cache manager they have to use. Now you can basically specify that either at class level, so you can specify the key generator and the cache manager in the cache config annotation we just saw, or you can even tune it down to the operation itself. So you can really now fine-tune declaratively what we want to use, how you want to customize the cache aspect. Something that came from, and jumping a bit ahead here, something that came out from the JCache support is GSR 107 has this notion of cache resolver, which purpose is to resolve the cache region to use based on a method invocation. Previously, what we are doing in Spring 4 and well, Spring 3.2 plus actually, was you pass a cache manager, you specify a name on the annotation, and we use that to actually call the cache manager with the name you've set on the annotation and get the cache out of it. What we've done with cache resolver is extracting that logic in a separate interface so that you guys can implement that interface, customize that, so you can also customize that at class level and you can customize that at operation level. To resolve the cache whenever you want. And also, a new feature that comes out of it is you can now resolve the cache you want to use per method invocation. So if we look at one typical implementation we could use for this cache resolver and illustrate a bit the cache operation invocation context here, would be this. So there is a convenient abstract class you may use if you're working with a single cache manager. If you have several cache managers in your application, maybe you will need to implement cache resolver directly. Well, it depends on your use case. And what abstract cache resolver gives you is it gives you one method to implement to return the name of the cache, and we do the same logic of using the cache manager that you specify to resolve the right cache. If the cache isn't found, we throw the proper exception for you, etc., etc. So that simple implementation, what it does is it's simply passing the object type on which the cache aspects have been set and return the region names to use. So one simple implementation would be I give you book repository and you give me back books, the string books, which is the name of the region. If you do that, so if you have this simple implementation, and meaning you can extract all your logic of applying region names outside your code. It sits in configuration or whatever means you want. You configure the cache resolver at the application level, and you basically have this. So you have the same service as we just saw, except that you don't refer to region at all, if that's what you want to do. Of course, if you want to still specify the region directly in your code, that will work just fine. Right.
All right. We've already had a forward reference to GSR 107.
Yeah,
there.
go ahead.
GSR 107 is a big driver, right, for what we're doing in Spring Framework 4.1. The spec itself went final in April, I think, this year. So just a few months ago, basically. The spec itself tries to provide two things, somewhat independent parts. One of them is an annotation-based cache interaction story, which is basically the equivalent of what we've just been discussing in terms of Spring Framework's caching annotations. The other part is a cache SPI specification, which I would actually consider the real reason for turning this into a spec, where different kinds of cache providers, such as JCache, Hazelcars, Terracotta, whatever, they could all provide an implementation of GSR 107. Be GSR 107 compliant in shipping a GSR 107 cache manager implementation that comes with the right metadata for it to be detected through GSR 107's bootstrapping mechanism. So it also has a bootstrapping mechanism for the cache manager. But let's look at the annotations first. This is an equivalent of what we've been seeing before, but expressed using javax.cache annotations, as you can see from the imports above. This is not using Spring annotations. We're using standard GSR 107 annotations to express the same interaction patterns. There are quite a few things you cannot express here. So JSR 107 has its own ways of doing a few things, but this is all perfectly compliant. A specific key generator can be seen down here with @cache result. @cache result is basically @cacheable from a Spring perspective, very analogous. There's @cache put and there's @cache remove, the equivalent of @cache evict. In terms of runtime behavior, what you get out of this is basically equivalent to what you would get if you were using Spring's annotations. So the examples are, in terms of runtime effect, they are basically equivalent.
And
this is a...
Yeah, sorry. And something also to mention is, you probably saw it, the cache put semantic is a bit different. So when using the Spring annotations, we call the method, and the return value of that method invocation will be used to update the cache. With JSR 107, you have to provide the value you want to update to the cache, and you have to annotate that with cache value. So if you forbid to put cache value, it will break.
This is the reason why. This is a book argument instead of a return type.
Right, right. And there's also, if you're wondering how you can customize the ID generation system, there is a what's the name again? Oh yeah, we have it. We have it here. The key generator, custom key generator. But you can also, like I mentioned previously, there is also this notion of cache resolver in JSR 107. So you have to provide a factory, which is not mentioned here. You have to provide a factory class, which will give you back the cache resolver, and it's basically the same thing. Regarding ID generation still, you may be wondering what would be the translation to the spell expression. So composing complex IDs, so if you have several method arguments and only a few of those, or only one of them, are used to compute the ID. There is a special annotation you may use, which is a JSR 107 annotation, obviously, called cache key, sorry. And if you put that on a method argument, only those will be used to compute the key. But there is no way to, like we can do in Spring, to have a complex spell expression or whatever. So it's either all arguments or only the ones that are annotated, that are being used for the ID.
Right. That's to be expected, those sorts of differences, because JSR 107 has its own little world that it's modeling. And there are different origins in some of those, some of the design of the annotations. But fundamentally, this is a continuation of Spring's story of supporting standard annotations to express common concerns in application component classes, avoiding Spring imports, avoiding Spring Framework imports in those commonly used service or repository classes in your code base. Those can live side by side. So some of the classes could use Spring annotations, Spring caching annotations. Other classes could use JSR 107 annotations. There's nothing wrong with that. Would we recommend that? You would typically pick one set of annotations or the other. If you are in control over the code base, that's what we, of course, would recommend just for stylistic consistency when going through your own code, finding a consistent set of cache interaction annotations. Right, so the JSR 107 annotation story, of course, also needs some background configuration. It's not that different. Actually, it's not different at all. We have an @enable caching model that detects JSR 107. So we find out for you whether the API is on the class path, and we activate the infrastructure accordingly, depending on what we find on the class path. So this is all that's needed. Just put @enable caching up there, have the JSR 107 annotation API on your class path, of course, and use it in your code. We'll auto-detect it for you and react accordingly. The backend configuration that you can see here is a Spring Cache Manager implementation. So Spring supports JSR 107's annotations against a Spring Cache Manager backend. Works perfectly well. The idea is that the Spring Cache Manager abstraction is actually significantly better established in the industry than JSR 107's. We have a number of Cache Manager implementations out there. And those can be used for the backend configuration your front-end classes can use standard JSR 107 annotations. It's actually a pretty good combination to have at this point. At the same time, we do, of course, support JSR 107's way of bootstrapping. There's a JCache cache manager, which actually has been out there since Spring Framework 3.2 in an early form, and since Spring Framework 4.0 in a JCache 1.0 GA compliant form. JCache cache manager is just an adapter, right? It adapts to the Spring Cache Manager SPI contract to the JCache way of bootstrapping a cache manager. So if you set it up like this, basically check your JCache setup, do it the way JCache wants you to do it. It auto-detects a cache manager implementation on the class path, selects the implementation for you, has its standard locations for configuration files and so forth. So that's basically it. The choice is up to you. Spring allows for quite a bit of flexibility here. Using Spring annotations against a Spring Cache Manager backend. Using JCache annotations against a Spring Cache Manager backend. Using JCache annotations against a JCache backend. And even going as far as using Spring annotations against a JCache Cache Manager backend. So we allow you all possible combinations here. It just works. The gist of this story is set it up as you want it to have, choose what you want to use in your application components, choose the best possible setup option in the backend, we'll care for the rest. Right. So to wrap up this section.
Yeah. So as you've seen, especially thanks to the users' feedback and great community feedback, Spring 4.1 has improved its declarative model for caching. And lots of things where you had to fall back to coding stuff yourself. Now you can use out-of-the-box options. So we've seen those. The cache resolver, which allows you to resolve the cache to use at runtime in a much more fine-grained way. The class-level customizations, which allows you to share common settings for your service without copy-pasting the redundant options. And even method-level customizations, which, by the way, works per operation. So you probably know that a method can apply several cache aspects. So you can have, for instance, a method that would cache evict one region and cache evict another region. For this specific cache evict operation, you can also customize, even though it's applied on the same method. So each cache operation can be customized any way you want. The JCache support gives you an option to use the standard annotations if that's what you want to do. We support that automatically. It just works. Just if you start using the JSR 107 API on an app that has enabled caching or the cache annotation-driven XML element, we will just make sure that the right infrastructure will be in place to support those annotations. And more importantly, if you have an app that's using the caching system already, you don't need to change anything in your config at all regarding the caching backend. So you don't need to upgrade your caching library because you have to wait for it to support JSR 107. You can use it today with the standard annotations and it will work. There's also a few other things that we've done, let's say more core-based and not especially something that you could use declaratively, but still useful. If you guys use the cache interface directly, we've added a putifabsent method on it, which is the method you would expect from concurrent hash map. We've also improved the exception handling. So previously, if you invoke a method that has a cache aspect on it, and we look into the cache implementation to figure out if we have a cache hit, so looking if there is an object with that ID, and the caching implementation fails on us, throwing an exception or whatever. What we were doing previously was throwing that back at the caller. So that's something you may want to change. So as of Spring 4.1, there is an interface you can implement to handle any operation that applies when we call the caching implementation. So you can decide to translate that if that's what you want to do, or you can even decide to catch the exception. So in the case of the cache hit that fails, you can transform that to a cache miss and just have your method being executed and the value put in the cache again.
Right, maybe worth mentioning at this point, since it's mentioned above here, for the common cache interaction patterns, there's no need to fall back to any kind of programmatic access. That's the point of the annotations. They cover the like 80% use case. So if your interaction pattern matches what our annotations or JCache's annotations provide, then they are a really convenient, declarative way of expressing this in your source code, in your code base. And it's even in a kind of aspect-like way. If you don't have any caching setup active, your code is going to keep working, just not as efficiently. That's the reason why our annotation is called cacheable, but it applies to JCache's annotations just as well. So that's kind of one of the little twists. If there is no cache manager setup, no cache processing setup, your code keeps working. It's just cacheable. It can interact with the cache, it doesn't have to. That said, if your use case, your interaction pattern is not covered by those standard annotations, there's always a way to express this programmatically. Add inject your cache manager, grab the cache region with a get cache call, and then perform get calls, put if and calls on it. That rule still applies. There are more cases now covered by the annotation model, but there's certainly still at least a 10% part left that's best expressed programmatically. If you want to talk to several cache regions, if you have to do cross-cache updates or cross-cache evicts of any kind, by all means, fall back to the programmatic API. That's a standard Spring Cache Manager, standard Spring Cache API. It's meant for that purpose. Even if from a design perspective, we consider it a fallback option because the annotations are just nicer and transparently laid over your methods instead of being hard-coded through programmatic cache manager calls where a cache manager needs to be there. All right. That's a perfect point for some Q&A on the caching part because we're going to move on to the messaging part next.
So you showed the difference between the JSR 107 and the cache key generator. I'm assuming that because yours is a string, I assume it extracts from the Spring context, like it pulls a bean out of the Spring context. This is the one that does based on a class.
That one?
Yeah, because it looks like you can't make ISBN cache key generator here state, like have some kind of configurable state, whereas in the Spring annotations you can't. Is there a way to solve that?
So the question is, we have that's the ISBN you were talking about, right? Yeah, we have an ISBN cache key generator .class here. So the JSR 107 annotation asks us to provide the name of the class, and we can do whatever we want with it. And the question is how can we provide some state or even lookup for a Spring Bean for that class? And the answer is it's done automatically. So if you happen to have one bean of type ISBN cache key generator, we're just going to grab that for you automatically. And if you don't, we're just going to create a class. And if that class happens to have annotations or whatnot, we will honor that. So we'll turn that into a Spring Bean.
Does that end up in the context in the Spring context?
No. So if the bean does not exist, we create one for the purpose of the cache aspect, but we don't publish it into the context.
That's the best we can do to follow JSR 107.
Yeah, because the life cycle won't work. And
it's not one, it does a new one.
No, of course not. Yep.
So you have this example on the repository layer. Just bring up two questions. One might be strategy, caching in the controller service versus the repository layer. And the other would be if you are using JPA and Hibernate, this caching versus their separate local cache.
Okay, two questions.
Yeah, so, both very valid questions. So the question number one, right? Would you cache at the repository level, or would you rather cache at the service or even controller level? That's, of course, an architectural question. Generally speaking, yes. I would say it's even primarily meant to be used at the highest possible point where caching makes sense in your architecture. That may be the service level. The controller level is a bit of a different story. Since we have plenty of support for HTTP-based caching at the controller level, I'm not sure you're going to use Java-based caching at that level. You could, but it's not exactly meant for that purpose. The service, if you have a service level in between, that's a perfect point to apply caching to it. At the repository level, it depends on what your typical repository implementation is. Connecting to the second question, what if you're using JPA or Hibernate, an object relational mapper that has an internal cache anyway? It has a second level cache, maybe interacts with the edge cache directly through its own SPIs. There is, of course, a difference in what is being cached. Since the object relational mapper basically caches a flat representation of the state of certain objects, it reinflates them every time you grab them from the cache. So the representation is slightly different. Here you cache the actual, basically, domain objects, the interaction objects expressed in those methods. Based on that, basically, you may choose one over the other. But the other part is, there are plenty of repositories not based on an ORM. Right? They could interact with external systems, maybe they perform REST calls to some other systems, sneaking them in through a repository here. And caching at that level makes a lot of sense when your target is basically not backed by its own caching model. But point taken, if you have caching set up in the JPA world, that may be perfectly sufficient. There may be no need to layer additional caching on top of it. Caching is always meant to improve the efficiency, the performance of your interaction, your typical interaction. If it's perfectly fine, there is no need to add an additional layer of caching. You could specifically do it for like commonly used objects where you maybe perform some additional post-processing after Hibernate returns them to you. There may still be a reason to cache them here, because here you cache the end result that your application uses from then on, not the initial object that the ORM returns to you, if there is a difference between the two. So that's basically, it's completely up to you. Those are options. There's always a risk to overuse them, so please do check that you don't perform too much caching, right, in your system. But yeah, those are the options basically, and they are somewhat orthogonal to each other, so it can be layered on top of each other, but are not exactly meant to be combined that way if there's nothing happening in between. Right. Other questions?
Yeah, in the
at
back.
this point.
So I'm more than happy to have Spring imports in my class to take advantage of the speed of innovation that you guys provide, and only use JSRs when there's really compelling reason to stay at the pace of that process. But is there some compelling feature from an application container or something from management and monitoring perspective why I would want to use JSR 107?
So the question is there anything compelling to use the standard annotations for management or monitoring purposes? I would say, I don't know, but the spec is, like Juergen said, the spec has been finalized in April this year. I'm not sure there are a lot of systems and libraries out there that use that now. But the point is, if that happens, the good news is that you can easily transition from your current system to those annotations.
It's to your specific question whether there's any additional runtime value like monitoring and management provided. Not as far as we are aware at this point.
Yeah.
There is no, JCache is not supported in any known runtime environment. It can be added just as a library, so it's a bit like using JPA on Tomcat, that sort of style, but you're not getting any additional management or monitoring that way. So from the present day perspective, it's like more the other way around. If the JCache model is expressive enough for your purposes, you may choose to use it because you like to use standard imports. But if you're perfectly happy with the Spring model, there's really no need to jump over to JCache just for that reason. There's no additional value provided, just a different style in terms of how you express yourself. So to the current, from our current understanding. In a year's time, in 2 years' time, there may be reasons to use JCache for system integration reasons because I don't know, cloud platforms may support JCache. Java EE 8 application service will have to support JCache. There may be additional value provided at that level. When you obtain the cache manager from JNDI, maybe a JCache cache manager, and it's decorated with some management and monitoring pattern. It's certainly conceivable that that is going to happen, but that's kind of an investment into future arrangements, not because that would be the case right now.
And maybe to complement the answer, there's a few things that JCache supports. Really, I wouldn't call them corner case, but there are a few features that JCache, because of its design, supports that we don't support in our own abstraction. The most famous one is exception caching. So when you enable the JCache annotations and you invoke your method and your code fails, or whatever you call fails, JCache allows you to cache the exception that has been thrown, so the exception object. So that the next time you call that method, you're probably going to put a time to live option on that cache. The next time you call the method, it will throw the exception directly back at you instead of calling the method again. That's something that JCache does that we don't. For various reasons I could explain very deeply, but not now because it's quite complicated. And we don't have the time to do it.
Yeah, the simple answer, we're not exactly sure that that's such a good idea to
cache
exceptions.
Okay, thank you. Okay,
if it were, we would probably support it in our own model as well. But if you're using the JCache annotations, we support it just like JCache wants us to support it.
Yeah.
All right. Last chance, caching questions?
Yeah, there's still a question there.
We've done a lot of work with like the cache, like blocking cache and self-optimized cache and stuff. Are you planning to have any kind of support for that for other caches? Because that stuff is super useful.
Yeah, that's a very good question. So the question is, cache provides advanced feature with blocking cache and self-populating cache. Do you guys intend to support that? Sorry?
For other caches.
For other caches.
Spring and not cache.
Yeah, right. Other cache system, you mean? I don't get the last part.
I was saying, like, that's all in cache. I would love to have that configured in Spring.
But for other cache providers.
Okay. So yeah, that brings us back. That brings us back to very interesting discussions on the issue tracker with a lot of users, and here internally. We had lengthy brainstorming about the subject and also checking with people that are basically doing that stuff to get their advice. For blocking cache, so blocking cache, for those who don't know what that does, is it's basically allowing you to prevent other threat to retrieve a value if the value is being computed. So let's say you have an app that starts, you have 10 threads that are trying to get a value with ID 1, for instance. The first thread that starts to actually load that value, so basically calling your method here, to compute the value and returning that and basically cache it into the underlying cache. The 9 other threads are stuck until the first one completes. The reasoning behind that is if you have if you cache the method, it's probably because it's lengthy and it takes some time. So the idea is to prevent that the 10 threads are computing the same thing and basically returning the same value. The problem with blocking cache is it has all kinds of side effects if we try to put that into a generic API. Playing with threads, and you need to change completely the way the caching system works because you need to pass a callback instead of calling the thing directly. Actually, blocking cache, if you look, and maybe we can chat together after, if you look, there is one issue in the tracker that we fixed that allows you to use it. But
it's all with the cache.
You need to tweak it a bit, and it will work. But we've decided, okay, we can come back on that decision, but after lengthy brainstorming, we decided that bringing back those features in an abstraction is basically like if we started to implement Hibernate instead of the GPA, instead of supporting GPA, trying to bring advanced feature, which is not what we're supposed to do. So the answer is no.
We support it if the cache provider supports it, but we're not going to decorate the cache provider.
Yeah.
That's, I would rather make it the cache provider's problem, right? Raise an enhancement request with them. Could you please provide a blocking cache equivalent for whatever you were doing, like if you're using Hazelcast or whatever. It's best implemented in the cache provider itself, not through decoration.
Yeah.
There are all sorts of unpleasant effects if you decorate it on top of a cache provider that's not meant to be used that way. That's the reason. Right?
And it's the same thing also for transactions. So we also get a lot of users asking us to integrate at transactional, whatever that means to them, and making sure to update the cache only when the transaction completes. So trying to fill that gap. And the answer is the same. If you want to do that, you need a transactional cache. And if we try to do that ourselves in the abstraction, I'm not sure we'll be able to fix that problem without having access to the underlying implementation.
There is a transaction-aware model where you can postpone the put calls. That's kind of an easy enough thing to do, and we are providing that option. But yeah, any actual transaction interaction means the cache needs to be aware of the transaction, and we can't make it aware through through decoration, right? It's really something the cache provider internally needs to be prepared to do. Anyway, for the sake of timing, let's move on. Thanks for the questions, by the way. There were quite a few here, quite a few interesting ones here. Right. So let's move on to the messaging part. In the messaging domain, we have quite a bit of established functionality, of course. You may be aware of Spring's GMS module, has been out there for a long, long time, providing GMS template and co, but also providing a listener model. There's the notion of a message listener container that we have, which is just configurable runtime infrastructure that manages interaction with a message listener that you're providing. So that's standard foundational support that we've had for a long, long time, since Spring 2.0 actually. Very flexible, very configurable, very adaptable to your runtime environment. For the purposes today, we're not going to focus on the backend so much, on the runtime processing so much, but more on the stylistic part, right? How do you express this stuff in your application code base? And there has been a model for callbacks to processing methods that do not implement any kind of message listener interface at this point. That has been around for a while. So this is actually an interaction style we've had for a while, a method that's typically called handle message. There can be several of those on the same class. They accept an incoming payload object. They return an object to be sent back to a response destination. Significantly nicer than implementing a message listener where you internally perform this wrapping and unwrapping. But that's basically as far as we went. There is XML configuration typically associated with it, this GMS listener container XML element. If you look at the GMS listener line, like down here, this one basically interacts with our message handler above. It refers to a bean called order message handler and says, like, call this handle message method for any incoming objects. Internally, it's going to create a message listener that adapts to that method, basically. The order message handler is a separate bean, and in this example, we also see a message converter involved because order and order status are not understood by default, of course. And in our example here, there's a Jackson GMS message converter setup that performs the conversion of the incoming payload, a JSON payload, let's assume, into an order object, and on the way back, the given order status object, it renders it back out to JSON. So this is what we had, pretty much what we had since the Spring 2.0 to 5 days at least, that would work. But as of Spring 4.1, it took a little. We turned this into an annotation-based model. Right?
Yeah, sorry. So what we wanted to do is basically give you an experience where the declarative configuration part is with your code, so closer to your code. So what we've done is introduce a new annotation called GMS Listener. If you are familiar with the GMS Listener configuration in Spring today, you can think of it as the GMS Listener child element that we just saw. So right now I'm just defining the destination that that method should listen to. And that's about it. So what's missing here is the value of what we call a container factory. So what we've introduced a concept called GMS Listener Container Factory, which basically is the component that is responsible to create the message listener container. If you have one that's defined with the name that we expect, and that's the name GMS Listener Container Factory, as you might expect, we're just going to use that. So we're just looking that bean from the context, calling it, it will create a message listener container for us with the settings that you've defined, and then it will create a listener on that queue. Pretty much the same way as what you have with the GMS listener container in XML. So if you look at the other options that we have, they look familiar to you if you've used that in the past. You can specify, of course, a different factory. So that's basically, if we translate to XML, you have a different GMS listener container element. Previously, the relationship between the two were explicit because the GMS listener is a child element. So the link is direct in the XML document, whereas here in code, we need to find a way to link it, and that's the name of the factory that we use for that. So you can specify a selector, a GMS selector. You can also specify a subscription name, which we don't do that since it's not a topic. And new in 4.1, you can specify the concurrency per listener. We've got a lot of users complaining they can't do that, and they had to fall back to non-namespace configuration just for the sake of this. So the XML part has also been updated, so there is a concurrency attribute on GMS listener element now. So if you want to stick with that, that will work just fine. So the POJO that we had before, we just added a GMS listener annotation on it with the name of the queue. So what does it take to actually configure that stuff? There are several ways you can do that, and as of the caching, what we wanted to do is, if you were using an existing configuration, we wanted to transition you to your existing configuration without forcing you to rewrite everything. So what you can do, you can stick with XML, add the GMS annotation driven thing. You probably, if you're using XML config, you probably know that from there is cache annotation driven and MVC annotation driven. There is all kind of context that supports that. So you add that to basically enable the processing of the GMS listener annotation. And we also add an extra attribute on GMS listener container called factory ID. And when you specify that, we create automatically a bean of type GMS listener container factory with all the customizations that you've put in XML. So if you update this app to Spring 4.1 and you update your config to this, it will just work. That's just a transition, a straight transition from what you had before. If you don't like XML and you still want to have, let's say, nice config support for GMS-based listeners, you can also remove XML and switch to Java config with an obvious enable GMS, probably something that you would expect. And that config is actually showing what's happening behind the scene with the XML counterpart. If you know, there is also the default message listener container and the simple one. We have that counterpart for the factory, so there is a default message listener container factory and a simple one. We put those customization there. So in this case, we specify the message converter we want to use, and that config is also working the exact same way. So the three configs that we saw. Spring 4.0 specific without the GMS listener, the XML one with GMS annotation driven, and this one, they all behave the same way. And now that we have saw the config, maybe it's time to see what a GMS listener gives you.
Those method signatures, the GMS listener method signatures, are pretty flexible, as you would expect them to be. Very similar to other endpoint methods, Spring MVC handler methods, for example. The same idea, the same style, really. The most common one is basically, as you've already seen it in some form, just accepts the incoming object, gets the payload, does something with it, gets it pre-converted, of course, with the message converter set up in the background, and an incoming, the incoming object comes from the order destination, so we would register with this order queue or whatever it happens to be. So that's the standard variant. We can always fall back to a variant where we don't get any conversion, where you get more like lower level access to the incoming message. This is equivalent to a session-aware message listener implementation, that good old interface, but in this case it's expressed in a method signature, and there can be many methods of that style on the same class, instead of providing several classes, each implementing session-aware message listener. So there's even a benefit here. You get the JMS session and the JMS text message, and you can basically do whatever you want with them, extract headers, create response messages, whatever it is. You don't get any payload conversion that way. You just get the way GMS provides it to you. This is sort of equivalent to a Spring MVC handle method that gets access to an HTTP servlet request, HTTP servlet response. You can do that in Spring MVC at any point. It's again for this 80-20% split. If you can get away with the convenient model, pre-conversion, nice arguments passed in, then by all means do it. But if your use case cannot be expressed based on the declarative version, then here's always an escape hatch built into the model, allowing you to dig a level below. Right. There's quite a bit more you can do, since there's a flexible little handler method factory in the back of this that can be customized with all sorts of things. So you can also customize how an incoming object that is about to be converted and passed into your method, how that object is to be treated, how handler method arguments are to be resolved. All of this is customizable. Just like in Spring MVC. If you know the invocable handler method model in Spring MVC, it's the same kind of style. There's a backend factory for the handler methods that allows you for customizing how arguments are being resolved or how they are being pre-processed before they enter your method. There's support for validation through a specified validator. The add valid annotation, like in Spring MVC, next to an argument means we perform a JSR 303 typically compliant validation step, but anything that can be expressed using a Spring validator would work as well. Before we pass the object in, you get it in pre-validated form. There is a way to additionally access a couple of headers.
There's a question there.
Oh, yeah. By all means, please. If you get validation failures, it's basically the same processing model. If there's a binding result next to it, the idea is that you get them in pre-validated form. The question or the point is, if you don't do that, you're never going to see an invocation here. It's going to fail before it even enters your method and going to blow up with basically an exception that's generically processed. So in that sense, it may be a good idea to do that, to handle validation failures yourself. But it is the same model. The whole idea is that this endpoint model is as analogous to Spring MVC handler methods and to Spring 4.0 message mappings, STOMP message mappings for WebSockets, as analogous to those models as possible. You basically find yourself in the same stylistic world, the same kinds of interaction patterns, even the same kinds of annotations in some cases. As with add header here. Add header allows you to extract specific headers from the JMS message. Because keep in mind, if you are asking for a pre-converted payload, you get a pre-converted payload, but no message context, no message wrapper around it at this point. So if you want to access headers, there's, well, one way is to fall back to that model above, right? A JMS text message, that's JavaX JMS text message, right? That gives you access to the headers, of course, but no converted object. So what we see below here is a way to get a pre-converted object and express access to specific headers. In this case, the order type name is significant, so we actually perform parameter name discovery, and we are going to obtain a header named order type for you. So that's in particular if you only want access to a single header or two, then that's a good idea. And of course, you may return an object to be sent back through a response destination. There's an add send to method, add send to annotation that you can add to the method, allowing you to customize where to send the response to. So it's specifying the response destination. Something you could also do in the XML model, for those of you familiar with it, this is also available here if the destination differs. And if the destination, if there's no response destination predefined, this is a default response destination. It can be overridden for specific messages. Right, this is basically the standard GMS story. It goes a little bit further because I've already been referring to it a bit. There is a messaging abstraction introduced in Spring Framework 4.0, the org.springframework.messaging package. This provides even more commonality because this is basically the model used for WebSocket STOMP endpoints, also any kinds of similar endpoints in the web processing world. For message processing, we support the same types now. So GMS message processing can be delegated to methods such as the one seen here, which is slightly different from the last example we've just seen because it does not request access to the order object directly. It wants a message of payload type order. Message is org.springframework.messaging.message. So it's a common message type from the Spring messaging module, the same that you would also use if you want access to STOMP messages in web processing. Message of order gives you kind of the best of both worlds. You get a pre-converted payload object, and the message wrapper around it gives you access to the headers and other message context. On the way back, you may also choose to not provide an order status, which is just a payload object. You may want to provide a message of order status, using a message builder to take the payload object, build a message for it, add some response headers to it, and return it. So that's a really nice way to add response headers to the response that you're passing back. So and it's a nice way of commonality, right? It couldn't be more common than that. And we're not just supporting that for GMS, we're actually supporting it for AMQP as well. But that's a point we'll return to at the very end. All right. Last but not least, let's quickly also mention that there's a GMS messaging template, which is an interesting twist to the GMS template. This is based on org.springframework.messaging as well. It does not use GMS message types in its signatures. It uses org Spring Framework messaging types and implements common Spring messaging interfaces, such as message sending operations, message receiving operations, message request reply operations. At that point, it becomes an abstraction. You may interact with it through one of those interfaces. Any implementation of those interfaces will do. Whether it's GMS-based or AMQP-based, does not matter at that point. So you can use a message builder to build one of those generic Spring messaging messages and use your messaging template to send them. It's basically a variant of GMS template using org Spring Framework messaging types and providing a degree of abstraction that way, a degree of decoupling from the GMS model, including exception translation. There is no GMS API leaking through here. You may have spotted that there's an interface called message request reply operations specifically. We even provide additional interaction models here where you may have a single method passing in basically a message. You wait for the reply to come in. We take the reply and return it to you. So there's even some common interaction patterns additionally modeled for you in that world that are not even available in GMS template. All right.
There's a question.
A question.
Does the GMS template extend that or use it at all?
It uses completely internally.
Okay.
So basically, the abstraction that you get from GMS messaging template, you get all the abstraction from method signature, and internally it delegates everything to GMS template, which means that operation Juergen just mentioned is also supported if you access the GMS template directly.
So GMS messaging template delegates to GMS template, not the other way around.
That's what I said?
To say, yeah, it was right, but just to reinforce the point.
Yeah.
First question, is there a more generic messaging template available that's easy to extend and work with? Is there an abstract or class or anything?
of those, okay, the question is, do we have an abstraction for those generic interfaces so that if I want to implement that for a different protocol, I have all the base class, all the base methods implemented for me? The answer is yes. So if you look at GMS messaging template, you'll see that there are a lot of things that are already implemented by a base class. And at some point, there is a do send method, and there is the GMS template coming in. So if you have something else, you just put something else there.
We're using those ourselves also for the
Yeah,
MQP
yeah.
version and the generic version of those. Right, there's a demo waiting.
Yeah. Let's go for the demo. Let's go for the demo, and before doing that, change the settings here. So the idea is we're going to show you live the samples that we've seen today in the presentation. So for that, I'm going to use this, the new Spring Initializer. How many people have seen the new UI design? Only a few, OK. So what I'm going to do, I'm going to select GMS, because that's what we're talking about here, and the latest milestone of boot, which is 1.2M1, and the first version that's using Spring 4.1 internally. Generating the project. So that's basically going, if I have internet. Please. Can you stop browsing the web, please? For a minute? OK, if that doesn't work, I have a backup plan, so that's fine. That should be called demo, and increasing the font, sorry. Yes. So what that does, if internet was working, is it gives you a zip file. You saw that you could select if you want a Maven build system, a Gradle build system, which Java versions you want, if you want a WoW file, a jar file, whatnot, if you want Groovy, Java, etc., etc. Based on what you've defined, so what kind of project you want to use, it will give you a zip file with a project in it, and you can open that straight from your IDE very easily. Open project, that might be it. So since I've used the GMS, I ticked the GMS dependency, it gave me automatically all what I need to start building an application based on GMS. So we're going to replicate our order and order status class, and since you don't want to see me coding, I have those right here. Fine. Here we go. So the content of those classes does not really matter. There is an ID in one end, and you have a tracker number, I think, on the way back. But you can use whatever you want. So this is a traditional boot app. So you probably heard of boot already, auto-configuring things for you based on the class paths. I'm going to show you what that means concretely. So the first step is I want to create a factory for the container I'm going to define, and I'm giving it, if IntelliJ lets me, I'm going to give it the default name, so that in the annotation I wouldn't have to define that name as the container factory. If you're not happy with that name, by the way, you can change that through advanced configuration. Okay. So I'm not going to replicate the message converter thing, but you get the idea. The only thing that you need to define really is the connection factory you want to use. So the connection factory is going to be the object that you can create sessions from. And since I'm using a boot app, well, it's going to give it a connection factory for me. And we'll see how in a minute. The other thing I would like to do is, when the app starts, I would like to send a message on some queue, the order queue. So for that, I'm using a callback from boot called command line runner. Command line runner is actually being invoked when the app starts, and you get the command line arguments that have been passed to the app. I don't care about those. So I need a template. That's also something that boot will give me. If I haven't defined a template on my own, and boot figure out that there is a GMS infrastructure obviously going on in this application, it will create a GMS template, a default GMS template for me. Okay, create an order first. So what do I have here? Super ID and super customer. Those are not ID meant to be used in a real application, just saying. And I use my template, give it the name of the destination and the object to send. And convert and send is going to convert it with the default message converter, send it back. Send it as on the queue. So I have a component that's sending the message now. I want to define a component that listens for that message. So let's do with the order runner thing here. Process order, or whatever you want. Do I have that? Yes. I have some tricks to save the typing. And GMS listener, which fails because I need to provide a destination here. I haven't defined a container factory again because the default one that I have has the name that Spring expects. So how does it work? Oh yeah, I forgot that one, to make sure that components can text it. What the Spring Boot Starter GMS provides you is an integration with HornetQ, and by default, it will try to figure out what it has to do. So if it doesn't have the HornetQ libraries in the class path, it's going to try to connect to an HornetQ instance running on your local machine with the default settings. But I don't want that. So I'm just going to add an extra dependency here. What's the name again? Something like that. Yeah. So I'm going to add basically the HornetQ broker, and Boot will auto-configure it, embed it into the app and everything. So if you want to try something out very easily, very quickly, that's the easiest you get. If I'm running the app now, it will fail. So at least let's see if it fails the way I expect it to be. No, it doesn't. Oh, what did I do wrong? Oh, right, I forgot the static here. It can't create the class because since it's attached to the instance. Sorry about that. So now it will fail as I expect, yes. So HornetQ, at least we didn't find a way. HornetQ does not allow you to auto-create the queue as they are required. ActiveMQ supports that stuff, but HornetQ doesn't, as far as we know. But obviously, hopefully, Boot has a support for that. So I'm going to ask it to create a queue for me. And maybe do that a bit smaller. So application of properties, for those who don't know Boot, is a default location where you can specify customization to the way the auto-config is applied. So you can pass in a bunch of properties there. If the default auto-config does not fit with what you want to change a few things. For instance, you can also set that even though the HornetQ broker is on the class path, you still want to connect to a remote instance. There is a mode that you can define to do that. So if I run it again, here we go. I have my GMS listener and receiver. That's working fine. So that's really the basic example that you get. So what I want to show you now is how you can, once you have the infrastructure in place, how you can change your code and have it being taken into account very easily without you jumping back to config. So what I want to do here is, like we saw already, is, oh, I'm doing that mistake again. Jesus. I want to add a order type to order type header to my class. So for that, the only thing I have to do is to annotate an additional method argument with the header annotation. So it may not have been clear from the example that we've defined, but since we try to figure out which parameter you want, you can add as many arguments as you want and tell us what they mean. So if you have an additional header, you are going to define an additional header parameter, set the header annotation on it, and we'll try to figure out the value from the inbound message. So let's log that to prove that it works. And I need to set the header now, right? So what I'm going to do is I'm going to switch to the new messaging, GMS messaging template. So that's the abstraction. And I'm going to change that thing to a message. And using the API that we already have since Spring 4.1, and it came from Spring integration, so you guys probably know that for quite some time. Adding a header here and building. Okay, let's reformat that a bit. And I'm sending a message, the message that I have created. You also see that I haven't created a GMS messaging template. I just auto-wire it. Spring Boot 1.2 provides a few GMS auto-configuration for the Spring 4.1 features that we just saw. So it's just going to auto-wire that for me. And I get the object with the header. So if your model changes and you need to inject new stuff, you just do so in your code. You tell us what that means from the context, basically. And we figure out the rest and we inject the right value. The last thing I want to show, so that I give enough time to a QA, is how you can add an extra listener once you have that infrastructure. So let's do that. Static. So what I'm going to do is instead of just logging the order, I'm going to fake some processing and return an order status. And make sure that this message that basically is some workflow chain or whatnot is processed by a different listener, which is the order status listener. So you get the ID, process, status, or whatever name you want. You can inject this, for instance, if that's what you want. Just going to log it. It's not really relevant. I'm going to provide a different destination this time, or the status. And I'm just going to change the signature here. Order and super tracking ID. All right. And what I need to do now is I need to tell where the reply should be sent. So I'm going to add this here, saying send to order status. And I need also to define that queue so that it's available when the app starts. So I still have my simple sending. The processor now returns a status. It defines where to send the reply. And I have a new component here that's supposed to basically process that reply and do whatever it needs with it. And that works. The last thing I want to show you is, and actually it made me realize that I forgot something from the beginning, which is a proof that I forgot something. I forgot this, right? I forgot to type that, and yet it works. The reason why it works is because boot also auto-detects that for you. So you can remove that, and as a matter of fact, you can also remove all that completely, because that's the default one. And if there is no GMS is no container factory with the default setting, we just provide one. So your app now is basically no config at all. It's just code. And it should still work. Yes. Okay. For those who are interested by that, because we run out of time, just ask us after the talk. There are additional demos that we can show you if you're interested, especially in the bootcli support. So now you can also tweet GMS Listener if you fancy that. It will work. And back to not marine display. Do we have time? Yeah, we still have a bit of time.
Yeah, a few additional notes of interest. You can also programmatically register endpoints. You don't have to do it at JMS Listener way. That's also a new facility in 4.1. You can have a callback allowing you to register additional endpoints against the registrar. Here you can see stylistically what this looks like. You can use a simple GMS Listener endpoint, configuring it with the typical properties that you would also have on the @GMS Listener annotation, and then provide a message listener as a callback. And here we're using a Java 8 lambda, well, an incomplete Java 8 lambda, to pass in the actual processing logic that you would usually find within the annotated method body. And then you register the endpoint and you're done. You can also mix and match, have a couple of annotated endpoints, register some additional processing endpoints, maybe because the configuration needs to be dynamic. Based on some conditions, you would register an endpoint or not register it. So the typical flexibility of doing it programmatically, if you have to, as a kind of fallback, as an escape hatch, if the annotation-based model isn't sufficiently expressive for you or sufficiently dynamic for you.
And as you may expect, the GMS Listener endpoint is actually responsible to customize the message listener container that has been created by the factory. So if you have additional use case or things that you want to further tune using a dedicated endpoint implementation of yours, you can do that. So you can do my GMS Listener endpoint with extra attributes, implement the callback interface where we give you a container, you do whatever config customization change you want to do, and call that same method and it will work. So you get an open infrastructure to create custom endpoints if that's what you need.
Right. On a different quick note, we've also added some additional little fancy features to the underlying infrastructure. For example, a configurable backoff on listener container recovery. So we're talking about listener container recovery. A message listener container may lose its connection to a target broker and have to reestablish it. There was a model to do it before with a standard interval in between, but now you can provide a back-off strategy where you're saying like, okay, let's retry, but not retry with the same interval. Let's try to exponentially increase the interval up until a maximum interval that you want to use for the back-off, and at some specific point of time, just give up when a maximum has been reached. This is highly configurable now through a back-off strategy in the underlying listener container itself, for any kind of usage model. So it's on the actual listener container infrastructure. All right, for the sake of time, let's wrap up here. We've seen quite a bit of stuff. So there is, of course, the new annotation-driven endpoint model. There's the improved Java configuration story at enabled GMS, the GMS Listener Container Factory, all the little fancy ways of expressing the configuration in the configuration class. Well, we should add there's support in boot 1.2, which is currently in milestone phase, but about to go GA towards November at least, so it's not far away. There's full support for all of this, and really convenient support, as you've seen, for all of this in Spring Boot as well. We've seen and talked about method signatures, Spring MVC style, a little bit also, well, not a little bit actually, quite aligned with the way that we are handling messages in the Spring WebSocket support in the STOMP message endpoint model. We've talked about our variants of abstractions. We have org.spring framework messaging now, since Spring 4.0 already, common message types, a message builder model, providing a convenient way to use pre-converted payloads in addition to header access and so forth. We have a JMS messaging template variant to allow immediate interaction and also abstraction through implementing common operations interfaces, where you may choose to use the interface to be independent from the actual GMS infrastructure with the same code of yours being able to interact with, for example, the AMQP version of this. Yeah, we've also talked about the, how endpoints can be registered and container recovery. A note to be added here, we've also improved our GMS 2.0 support. The GMS 2.0 story has been started in Spring Framework 4.0. In 4.1, we added, for example, the shared subscription support. Our GMS listener containers are now able to deal with a shared subscription, a shared durable subscription, typically in GMS 2.0. So it's also fully up to date with GMS 2.0, but of course it doesn't require it. In the Spring Framework 4 generation, we're perfectly compatible with GMS 1.1 brokers, of course, because those are the common brokers out there. HonetQ is GMS 2.0 based.
Yes.
There are a few GMS 2.0 brokers appearing, and Spring is ready for it, for you to discover that it is talking to a GMS 2.0 broker, and then, of course, all those GMS 2.0 features are being unlocked for you. All right. One more thing.
And there's one more thing. And the Apple keynote starting in 10 minutes. So I guess the Apple fan out there will hope that Tim Cook is going to say the same thing. But there's one more thing to the presentation is everything that we saw today regarding GMS, that also works fine with MQP. So everything we saw, including, of course, the annotated endpoint, you get the same thing with Spring MQP 1.4 M1. So the rabbit listener annotation, the enable rabbit annotation, as you might expect. But more importantly also, all the messaging template implementation that abstracts from you from the actual broker type is also implemented. So there is a rabbit messaging template there, meaning that if you have an app that needs to change from GMS to MQP through config, you can do so now. You just implement your code against those high-level Spring messaging interfaces, and you can switch from one to the other simply using your configuration.
And Spring MQP is in milestone, right? Just like Boot 1.2, but it's in the same release cycle, so it's also supposed to go GA towards November, towards the Spring I/O platform 1.1 release train.
And if you're interested to try that and you download Spring Boot 1.2 M1, be aware that those autoconfig support did not make it. They are on master, so if you're using 1.2 snapshot, you'll get those, but they are not in M1. So you don't need to define the enable rabbit annotation, you don't need to define the rabbit listener container factory, etc., etc. All right.
Right. So far for the content that we prepared. Thanks for your attention. Those are pretty long slots, pretty long attention spans required. Are there remaining questions, in particular on the messaging part? But if you happen to have any on the caching part, that's of course welcome too.
Yeah.
For send to, can we send to a separate listener container? So I want to receive from your HonetQ, but send Kafka or send Rabbit.
So the question is, can I use send to send a reply to a different technology, so receiving basically on GMS and sending the reply to an MQP queue? The answer is no.
Not at this point.
But that's an interesting feature.
Yeah.
You can try it out and just report the issue and we can look at it. Yeah.
This is sort of a Spring Boot question. Every time I use Spring Boot, I'm excited to find that it auto-discovers something new, but I never know what it's going to auto-discover. Is there some kind of general flow chart? I haven't seen it.
Yeah, so the question is, Boot is awesome, that's what he said. But every time I use it, I would like to know what it auto-configures or what is available. So there is a report that you can use. So first you can use the app with the debug flag. And if you do that, when the app starts, it will give you a report of positive matches and negative matches. So for the positive matches, it will tell you which conditions have been met and what Boot has configured. And for the negative matches, of course, you'll get all the things that Boot didn't change. So if you inspect that list, you can figure out what you may miss if you, for instance, add an additional jar on your class path. For instance, for the demo that I've just done, if you try to start that with without the HonetQ GMS server dependency, and you start it. If you don't have on it queue, it will fail because it will try to connect to it. But in the negative match, you'll get, I can't auto-configure the embedded mode because embedded GMS, which is a class from on it queue, is not on the class path. Yep.
This is all 4.1, correct?
Yes.
Yeah. With a few of the things on the recap part have been available for a number of years, but the majority of what we've been mentioning here is all in Spring Framework 4.1. And just to double check, Spring Framework 4.1 has been released last Thursday.
Yeah.
It is generally available, so please don't get that part wrong. It's just the boot 1.2 and AMQP 1.4, which are in milestone phase. Spring Framework 4.1 GA and the entire GMS support we've been talking about is already generally available. As of November, AMQP and boot support for this will have caught up.
Yeah. Question in the back.
Since you're following kind of the MVC pattern, are there any significant testing pieces that come along with this?
So the question is basically, is there any support for testing those kinds of endpoints? Did I get that right? Well, specifically for the infrastructure that we're talking about here,
no,
not really. But they are based on common endpoint patterns, right? You accept payload objects, you accept Spring messaging message references. Those can all very easily be mocked. There's a generic message, a message builder. You can easily your unit test can just build a message with a payload and a couple of headers and pass it in. It kind of naturally comes with the abstraction. Doesn't really require specific mocking support. It can just easily be used as is. But in terms of actual infrastructure processing, we don't provide specific mocking for that part. So I would either do it really as a unit test with just messages passed in, messages returned, and having assertions against them, or bootstrap a local broker, like an embedded HonetQ broker that's easy enough, can be done in a test suite, like a little embedded integration test. We haven't really seen a need for anything in between those two yet.
All right.
Right.
Thanks a lot.
Thank you.